Hi folks, this is a solution for number 7 on part 2 of the Unit 5 review assignment. Okay, so this is a question here where they give us the longest and shortest days in Auckland, New Zealand. So here are the maximum number of daylight hours and the times that they occur. And they want us to determine the times over 2018, 2019 that there's going to be exactly 12 hours of daylight. So the first thing we have to do is determine a model. Okay, so we have our max and min. So from here we can calculate our A value and our C value. So our A, which is just our amplitude, so half the distance between these two. So it's 14.693 minus 9.632 divided by 2. Okay, so this is the one that originally had the error in the answers. So here 14.693 minus 9.632 divided by 2. Okay, 2.531. Okay, and then we've got the C value, which is our axis, so the number in between the max and the min. So here we've got 14.693, I'll show you that in a second, plus 9.632. Okay, so here we're adding them and dividing by 2. Okay, so 12.163. Okay, so here we just added them, found the average. Okay, so now here we're going to assume, I think it's a reasonable assumption to make, that the period is 365 days. Okay, so period is 365 days. Okay, could be slightly different, so it could be 365 and a quarter perhaps, but we'll stick with something simple. So this means that our K value is 2 pi over 365. And while you could certainly approximate this, I think it's probably worthwhile leaving it as 2 pi over 365 because that'd be a pretty small number. Okay, so the last thing we have to figure out if there's a need for phase shift and what parent function we're going to be using. Okay, so here we got to think that December 21st. So if we're starting on January 1st, so midnight at January 1st of 2018, means our maximum here occurred somewhere beforehand, okay? And it's on its way down as we get to the rest of the year, okay? So I can think of using a cosine function and shifting it to the left, okay? So here, December 21st. Now, I guess there's an argument to be made that you could shift it to the left by 10 or 11 units. Reason why I say 10 units is because, remember, it's January 1st at midnight. So, this might be December 21st at the end of the day. So in that case, there would be more closer to 10 days to the left as opposed to 11. But if you use 11, that would be fine also. Okay, so our phase shift here is we're going to need a shift of 10 days to the left, so negative 10. Okay, so now we can write our model here. So I'll use X and Y. So the number of daylight hours is given by, so again, we're using a positive cos function. So we've got 2.531 cosine of our K value, 2 pi over 365. And here X will represent the day of the year. So here plus 10, because I'm going 10 units to the left, and then plus 12.163. Okay, so this is the model that we're going to use, and we want to determine when there's exactly 12 daylight hours. Okay, so I've got this thing here. I'll save myself a bit of time, not rewrite it. So our first step is to isolate our trig ratio here, which is easy to do since this is has a linear form. Okay. Okay, so what do we have here? So we've got 12 minus the 12.163, so 12 minus 12.163, okay, and then divided by the 2.531, divided by 2.531. Okay, and so here we've got negative 0.0644. Okay, so step 1, isolate the trig ratio. Okay, step 2 is determine our two answers, which give us a cosine value of negative 0.0644. So this obviously doesn't relate to a special angle, so I'll do the inverse cosine. So the inverse cosine of my answer. Okay, handy little button we got there. And so here we've got 1.635. Okay, so we have 2 pi over 365 times x plus 10. Okay, this thing here is equal to, well, the inverse sine button gives us one of the answers, so 1.635. Not surprising that this is between pi over 2 and pi, because second quadrant, that's what inverse cosine gives me when cosine is negative. Or, okay, and now right away I find my second answer, which I'm going to get by doing 2 pi minus 1.635. Okay, so the other answer is going to be 2 times pi minus our answer, which is 4.648. Okay. Okay, so remember that step 1 was to isolate a trig ratio. Step 2 is to find our two possible answers for this cosine value using our inverse cosine and our related acute angle identity. Okay, and now I'm going to solve for x for each of these. Okay, so here x is going to be equal to, so what do we have? 1.635, so times 365, okay, divided by 2 pi. Make sure you put that in brackets or else you're going to get the wrong answer. Okay, and then we need to subtract 10. Okay, so our first answer looks to be about 85, the 85th day. Okay, and now let's do the same thing here. Second one, 4.648 times 365 divided by 2 pi. Okay, and minus 10 equal 260. Okay, now we need to find this for the next year also. So I could add 365 to these, but that's just going to make it tough to figure out a date. So what I did is I went online, and I can't show you that using this program, unfortunately, but I went onto this website that gives me the day number for the particular day of the year. So if I go to the 85th day of the year, I see that it's, oops, I'm looking at the wrong column. So the 85th day of the year is March 26th. Okay, so this corresponds to March 26, 2018. Okay, then this one here corresponds to, and now let me just find the 260th day. Okay, so these will be a little off from the answers I got because I had made a mistake in the initial equation. So 260 looks to be September 17th. Okay, or September 17th, 2018. And then when will this happen in 2019? Well, I'll just say it's March 26, 2019, since it's not, there's no leap year that we have to deal with. And this is going to be September 17th, 2018. Okay, now what you can do is I gave you a website where you can go check these dates and see how good an approximation that is. Okay, so you can go check that out yourself. But let's start with just a recap here. So I get my model, okay, by looking at the max, the min, the period, and figuring out what phase shift I need. From there, determine that I need to find a y value of 12, and then I use my algorithm for solving trig equations. So step 1, isolate the trig ratio. Step 2, find the two values which give me this cosine, okay, by using the inverse trig function and by using the related angle identity. Okay, and then once I have that, I can solve for my x and then determine all possible values using my periodicity here, which in this case here is 365. Okay, that's it for this one.